Here we go. We have 2 more graphing problems, right? On your test, I just went through, I made some tweaks to it and stuff, but you have rationals. I'm going to give you one rational that says, here you go, find the domain and the vertical asymptotes. Give you another one that says, give me the horizontal and the slant asymptotes. Give you another one and say, are there any holes? That sort of thing. After that, at the end, you will have something that you have to graph. You got to do all of it, okay? So make sure you guys are following along with me. Most of you, especially in this class, I will say, if I go through this list, you know where to find everything. It's the graphing that's a little difficult, but you guys are doing a really good job with this. So the first thing we need to do is we need to factor. Let's factor the numerator and the denominator and see what we can do here. What can you take out of the numerator? A 4, good. That's going to leave you with x squared minus 9. Okay, can we factor that a little more? Okay, so 4 and then what? Plus 3 and minus 3, agreed. Okay, now on the bottom, factors of negative 8, they're going to multiply to give me negative 8, but add to give me negative 2. Look at you guys, x minus 4, x plus 2. Are there any holes? No. How do you know that? There's nothing that's exactly the same on top and bottom. Go ahead and write none. As soon as you recognize that there's no holes or no slant asymptote or no horizontal asymptote, write none. So you guys get that off of your mental to-do list. Now let's find our vertical asymptote. When we find our vertical asymptote, we in turn are also finding what? The domain. Good. So just set, look, we've already factored it. Just set each piece equal to 0. X minus 4 equals 0. X plus 2 equals 0. So x is going to give me 4. Here I got negative 2. You guys agree? There's our vertical asymptotes at negative 2 and at x equals 4. If you want to write x equals negative 2 comma 4, that's fine. Just make sure you have x equals. So to find our horizontal asymptotes, guys, how do we find horizontal? Good. Compare numerator and denominator. What's the degree of the numerator? 2. What's the degree of the denominator? 2 what 2? Equals 2. So when you have degrees that are the same, you take the leading coefficient of the numerator, which is 4, over the leading coefficient of the denominator, which is 1. So your horizontal asymptote is at y equals 4. Well, what did we just figure out? If I know my horizontal asymptote is y equals 4, what did we just figure out? There's no slant. Very good. If you have a horizontal, slant is none. If you don't have a horizontal, you do have a slant. Can we figure out our domain? Okay, what is it? Negative infinity to negative 2, good. Negative 2 to 4, and 4 to infinity. Perfect. Your domain and your vertical asymptotes go hand in hand. Now we're going to find our intercepts. Guys, there's 2 different processes for finding the intercepts. X-intercept, we set what? X-intercept. Numerator, what? Equal to 0. Just the numerator. So you have 4 equals 0. X plus 3 equals 0. X minus 3 equals 0. Does 4 ever equal 0? No. So here I have x equals negative 3, and I have x equals positive 3. How do we write our intercepts, our zeros? Negative 3 comma 0. It's an ordered pair. We're putting it on a graph. It's an intercept. Write it as such. Make sure you write it as an ordered pair. Negative 3 comma 0, 3 comma 0. So now what do? How do we figure out what our y-intercept is? Every x, you make it 0. So my y-intercept, I'm going to plug in 0 for all of the x's. So I have 4 times 0 squared minus 36 over 0 squared minus 2 times 0 minus 8. Yep. So in my numerator, everything cancels except for my negative 36, correct? In my denominator, everything cancels except for the negative 8. Guys, what's a negative divided by a negative? Positive, good. And then, does 8 go into 36 evenly? No, but we can simplify it to 9 over 2. So your intercept is at 0, 9 over 2. All right, running through that is not bad. This is where we've got to kind of use our brains here. Let's look at our asymptotes. Let's look at our intercepts and see where our graph exists. So my two asymptotes for vertical are going to be at -2. Agreed? And what? -2 and +4. 1, 2, 3, 4. Right? There's 4, yeah. Those are my verticals. My graphic's going to get really, really, really close to those, but never do what? Never touch. Okay, where's your horizontal? At +4. Can my graph cross my horizontal asymptote? Yeah. Doesn't always, but it could. So now we have our sections. I have the left-hand side, I got the right-hand side, and I got the middle. So let's plot our intercepts. Where does this graph cross the x-axis? At -3, good, right there. At +3, and where do we cross the y-axis? 9/2. Where is 9/2? It's 8.5. No, it's not. 4.5. It's a little more than 4, right? It's right there above our asymptote. So if I'm looking on the left-hand side of the graph, you guys, we have up here and down here. To the left-hand side of our vertical asymptote, where do I know that my graph I already know it exists there? Above the asymptote or below? Why? Because there's an intercept there. So go ahead and draw it. If you want to plug in other points over there and check, that's fine. But since your intercept is there, you know that that's where your graph exists. So now I'm going to turn my attention to the right side of my vertical asymptote. What is a number bigger than 4 on the x-axis? Okay, let's plug in 5. Let's see what happens when I plug in 5, what value I get out for y. So I have 4 times 5 squared minus 36 over 5 squared minus 2 times 5 minus 8. Do I have all my signs right and all that? Okay, let's simplify, guys. What is 5 squared times 4? Is 100 minus 36, okay? And then on the bottom, 5 squared minus 10 minus 8, 7. Okay, let's simplify a little more. What's 100 minus 36? 64 over 7. All right, I don't know exactly what that is off the top of my head, but I know that 7 goes into 64 how many times without going over? How many times? You guys are hilarious. What's 64 divided by 8? 8? Okay, so it's like almost 8, right? 8-ish. Okay, so what I'm getting at is some of you are freaking out because you're like, I don't know my, what am I trying to say? My multiplication facts, okay? I understand some of you are getting hung up on stuff like that. Does it really matter that you put 8 or 9? No, just say I put 8-ish or 9-ish. What does it matter that the point is above or below what? The asymptote. What is your asymptote at? 4. The general direction. So if you guys make silly mistakes, you've got to pay attention to the negatives and stuff like that. But don't get yourself hung up on, I can't simplify 64 over 7. Just think a little bit. Is 64 over 7 above or below that asymptote? If I go over here to 5, say it's 8-ish, say it's 9-ish. If I go to 5, 1, 2, 3, 4, 5, 6, 7. I know it's somewhere where? Above or below the asymptote? Above, so you know that your graph exists here. Now, what are the possibilities for the middle? What are the two possibilities of shapes? A snake, good, or a parabola, all right? So think about this. I have an intercept on the x-axis. I have one on the y. So I know what's going on this side of my y-intercept. Do I know what's going on the other side? No. There could either be a point down here that's going to make my graph do this, or the point could be up here and it's going to make my graph do this. So what would be a good thing for us to plug in and check for?
It could cross
It can cross horizontal. Cannot cross vertical, but it can cross horizontal. So let's try -1. Let's try -1. If I plug in -1, let's see what I get out. So I have 4 times -1 squared minus 36 over -1 squared minus 2 times -1 minus 8. Correct? All my signs are okay? -1 squared is 4, and 4 minus 36 is -32. Yeah? All right, so 1 squared is 1. -2 and -1 is going to give me +2. So 1 plus 2 is 3, and 3 minus 8 is -5. Guys, first thing you need to do, what is a negative divided by a negative? Positive, okay? So when we simplify this, be careful with your signs. How many times can 5 go into 32 without going over? 6, right? So it's 6-ish. So let's see where 6-ish is. If I go to -1, I go 1, 2, 3, 4, 5, 6-ish. Where do you notice it is? Above or below the asymptote? Above. So what kind of shape is this going to make here in the middle? It's going to make your snake. But if I would have missed a sign there, make a big difference? Yes. Be super, super careful and diligent with your signs. Some of you guys are going to try and go 100 miles an hour. Don't do that. If you want to do this question first on the test, do this question first on the test. You don't have to go in order. Do whatever you're most comfortable with. Anybody have any questions? All right, let's go to the next one. And then we're finito. All right, we've had one where we just had one vertical, one horizontal asymptote. We've had one where we've had 2 vertical asymptotes, and we've had boomerangs on the side and a parabola in the middle. The last one we just did had boomerangs on the side and a snake in the middle. What do you think this one's going to have? A slant. It's going to have a slant. Okay, so let's look at this. First thing I'm going to do is factor. What can I take out of the numerator? An x. Okay, so 2x squared minus x, right? Minus 1. Somebody argued with me. First period. I won the argument. All right, can I factor this more? Yes, factors of -2. They're going to multiply to give me -2, but add to give me -1. Okay, so watch, guys. -2, +1, okay? So now I'm going to go on the bottom, and I'm going to say x plus 1. Whoops, not plus plus. X plus 1, x plus 1. And then they went, oh, well, good, there's a hole. That cancels out. Is that true? What did we forget to do? Forgot to divide by 2. That is a really common mistake that a lot of you guys do. If your A term is not 1, you've got to divide both factors by 2. So this actually becomes x minus 1 and 2x plus 1. And then on the bottom, you have your x plus 1, x plus 1. Do you guys have any holes? No. But with that one little mistake, would that have changed a lot of things about this graph? Absolutely. Just be careful. Right, now that we have everything broken down, let's find our vertical asymptotes and then in our domain as well. How many x plus 1s do you have? 2. Do I have to write them both? Why not? You're going to get the same answer, right? So you get x equals -1. Does that mean you have 2 asymptotes at the same spot? Okay, fine. Doesn't matter. You don't have to write them both. When you graph them, it's going to be in the exact same spot. So what is our domain based upon our vertical asymptote? -infinity to -1. Good. -1 to perfect. Good job. All right, so let's go to our horizontal asymptotes. What do we do for horizontals? Compare numerator to denominator. What's the numerator degree? What's the denominator degree? 3 is what than 2? Greater than. Look at your cheat sheet if you need to. What does that mean? None. Your horizontal asymptote is none. So what does that mean? There's a slant. How do we find slant? Long division. Good. So, come over here, do my long division. X squared plus 2x plus 1 on the outside. 2x cubed minus x squared minus x. What should I put at the end? Plus 0. How come? God bless you. We don't have a constant, so we need a placeholder for it, okay? So now we're just going to do our old-fashioned long division. X squared into 2x cubed. 2x. Okay. Get your subtraction ready. 2x and x squared is 2x cubed. 2x and 2x is plus 4x. 2x and 1, sorry, squared, and 2x and 1 is 2x. We have to distribute, yeah? Distribute, 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 distribute. What's a negative x and a negative 2x? No. Negative x and negative 2x. Negative 3x. What happens with negative x squared and negative 4x squared? Negative 5x squared. And then what happens with my x cubes? They cancel. And we do what with the 0? Bring it down. First term, guys, into first term. X squared into negative 5x squared. Minus 5. Do I have to go much further beyond this point? Nope. Negative 5 times x squared is negative 5x squared. If I distribute, is this going to cancel? That's all I need to know. Because what is the rest? It's a remainder. Do I do anything with my remainder? No. If you want to finish the problem, fine, but you don't have to. So your slant asymptote, guys, is that y equals 2x minus 5. We'll deal with that in a second. Do we have any holes? No, we didn't have anything to cancel out, right? So go ahead and write no, none, however you want to say it. Now let's find our zeros. What's another way to call zeros? X values, your x-intercepts. Okay, so let's set our numerator equal to 0, which we've already done. So I have x equals 0, x minus 1 equals 0, and 2x plus 1 equals 0. How many times does this thing cross the x-axis? 3. X equals 0, x equals 1, and x equals negative, whoops, yeah, my 1 just got a lot bigger than I wanted to. All right, so I have 3 intercepts. I'm going to write them as ordered pairs. So 0, 0, negative 1/2, 0, and 1, 0, correct? Are my signs right? Yeah. And then how do you find your y-intercepts? You plug in 0. So guys, watch. If I plug in 0 here, and then I plug it in here, and then I plug it in here, and then I plug it in here, and I plug it in here, what do I get? 0. So you have a y-intercept at 0, 0. Does anyone have any questions about how I found all of the stuff on our list? I'm going to have it listed out for you so you don't have to guess what you're trying to find. It'll all be there. I think I even wrote the words out like horizontal asymptote. I didn't leave it as ha. And I think they're all spelled right. I think. All right, so now let's talk about graphing. Okay, let's put our asymptotes. What is your vertical asymptote? Where? It is at negative 1. So I'm going to go here to x equals negative 1. What's the horizontal asymptote? Oh, yeah, that's right. I knew that. What's your slant asymptote? Y equals 2x minus 5. Guys, that is a line. That's it. You have y equals 2x minus 5. Where does this graph cross the y-axis? So 1, 2, 3, 4, 5. Is this a positive 2 over 1 or a negative 1? Positive, so it's going to be sloping upwards, right? So you're going to go up 2 over 1, up 2 over 1, up 2 over 1. Up 2, I went over 2, up 2 over 1, down 2 over 1, down 2 over 1, down 2 over 1, and so on. So do you see this other asymptote that you created? Do you see why it's called a slant asymptote? Because it is a slanted line, okay? Now, when we had just one vertical and one horizontal, we had 4 pieces of a graph, top left, top right, bottom left, bottom right. We have the same concept here. You have 4 pieces of a graph. You just have a slanted piece. Do you see this piece in green over here? And then do you see this piece in blue? Both of those are located on what side of your vertical asymptote? The left. So we're going to figure out, instead of above and below, we're just going to figure out which section your graph exists. Then to the right-hand side of the asymptote, do you guys see this section here? And then this section here. Those are that's to the right of the vertical asymptote. Do you guys understand what I'm saying there? All right, so before we start plugging in numbers, let's plot our intercepts. Where does this graph touch the x-axis? What are my x-intercepts? 0. Where else? Negative 1/2, and where else? And 1. Where does it cross the y-axis? At 0. So in regards to the right-hand side, guys, does your graph exist in the red or the gray? How do you know that, Chris? Because that's where all the intercepts are. So I don't need anything real specific. I just need you guys to be in this general area. How did we know it was there? Because that's where all the intercepts are. It's going to be one section to the right of your vertical asymptote. It just happens to be in the red part versus the gray. So now we're going to look to something on the left-hand side of the vertical asymptote. It's either going to be in the green version, or green section, or the blue. Just, you can make, it could be a variety of shapes. With you not having your graphing calculator, you're not going to get the correct, 100% correct shape, but just make it some sort of a parabola type thing. Some of them will go like this. I'm not concerned about that. I'm concerned that you understand where the graph exists. Just don't cross over your vertical asymptote. All right, if you come over here a little bit, I'm fine. Just do not cross over your vertical asymptote. What I'm looking for, Chris, is that you understand it's up there and not down here. Let's look over here. To the left-hand side of your vertical asymptote, what is the number to the left of the vertical asymptote? -2, okay? There's going to be a lot of 2's in this, guys, so just pay attention. Make sure I do this right. So it's 2 times -2 cubed, right? Is it minus or plus? Minus -2 squared minus -2 over -2 squared. What's the next one? Okay, plus, thank you, plus 2 times -2 plus 1. I knew there was a lot of 2's. All right, so let's simplify. What is -2 cubed? -8 times 2 is -16, okay? Then I have minus, what's -2 squared? 4. Then I have plus a negative, minus a negative, which gives me plus 2, yeah? Then on the bottom, 2 squared is 4, minus 4 is, so I'm just left with 1. Okay, so -16 plus 4 minus 2 is -18 over 1. So when I plug in -2, I get out -18. Does that exist in the green section or the blue section? If I go -2, so then I go down 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Where does it exist, guys? In the blue section, somewhere down here. So all you would need to do is just give me a little boomerangy looking thing, that's fine. But to show that that is the area of the graph between those asymptotes where the graph exists. These won't be. The ones that I'm giving you won't be. There's all kinds of different shapes, but since you guys aren't actually using a graphing calculator, it would be virtually impossible to figure out the exact shape because you'd have to plug in like 10 different points to kind of see what it would give you. But yeah, it could be a bunch of different things. Yep, that's fine. If you get a slant, just go ahead and do that. It's easier. All right, so what I want you guys to do right now, you have 15 minutes or so. I want you to pull up the review and just look at it. See the stuff from section 2.5 that you guys are going to be required to do. All the stuff from 2.6 and 2.7. If you want to start working on it now, great. If you want to just set up a problem and ask me a question, great. But please do something with it before you come into class on Monday. Because you will not get the whole thing done in class on Monday. You're just not going to. So just please do a little bit of something before you come in here. Sound good?